Hello, welcome to our final lesson in this batch of lessons on AC circuit analysis dealing with power transfer. So what we have is this problem, and basically it's a simple, well, sort of intermediate, I guess, level problem where we have a voltage source, 20 volts at an angle of 0. We have this network here that has some inductors, capacitors, resistors. We have the load terminals A and B, and we have a load hanging on the end. We want to figure out what value of this load impedance yields maximum transfer of power from the source to the load. All right, and in the case that we build this load and connect it, we want to know what is the maximum average power that's transferred. So again, I'm going to reiterate to you that when you're calculating max power transfer, you only care about real power watts. You're generally not concerned with Q because that's an oscillating factor anyway. You want to adjust things so that you get maximum number of real power watts delivered to your load. All right, so the condition that we want is we want to make sure that this load impedance is equal to the conjugate of the Thevenin impedance of this entire network that precedes it, you see? So in the previous problem, I already kind of gave you the simplified version where it was a really simple network. It was real easy to do that, but now we have a more complicated network in place. So in order to choose this, we have to first figure out what the Thevenin equivalent is of this entire thing over here, all the way up to terminals A and B. Then we'll know the Thevenin impedance and we'll be able to select the load impedance that works, and we'll just proceed after that point, as we did in the last problem. Now, there's a million ways to do this. You could find open circuit voltage right now using this network that's in place. You could do other things. I've covered Thevenin equivalents a lot. So we're going to be, doing it the way I kind of chose to do it. What I want to do is, because I have a voltage source here and I have a resistor right here, and then I have this nice ladder network like this, I'm going to do some source transformations. All right, I'm going to do a couple of them actually, just to simplify the circuit. When I get it down to a simple enough form, then I'm going to go ahead and calculate the open circuit voltage here. I could calculate the open circuit voltage here now, it's just that it would be a little bit messy. So let's do some simple source transformations. If you remember, anytime you have a voltage source in series with a resistor, you can change it into a current source pointing up, because the current would be coming out of the source here, in parallel with this 5 ohm resistor. So I can just change it. I just need to figure out what the value of that current source would be. And the value of that current source is just basically going to follow Ohm's law, V over R, where the voltage is given as 20 at an angle of 0 degrees. By the way, this is not an RMS. This does not say RMS anywhere, so you need to assume that it's not RMS, it's magnitude, which will come into play later. And this will be over 5. So that's going to give you 4 amps at an angle of 0 degrees, right? Now, if this is real foreign to you, if you don't have any idea what I'm doing here, then you need to stop and go back and review source transformations. I covered this in quite a bit of detail. So now, unfortunately, if you're going to get confused if you don't start redrawing the circuit pretty frequently. So we're going to spend some time redrawing the circuit. So what this means is this circuit now looks like the following. I have a current source going up, and now it's in parallel with this 5 ohm resistance. And the value of this current source is 4 at an angle of 0 degrees, and that's amps, and this resistance is 5 ohms. So this basically comes straight away from this right here. I'm doing a source transformation from voltage to current, like that. The rest of the network stays exactly the same. So I'm going to just quickly scribble that down. I don't want to spend too much time, but basically everything else in the network remains completely unchanged. So this would be the load over here, like this. So we have the load impedance, we have negative J6, this is terminal A over here, this is terminal B, this is J3, this is 20. I know it's a little boring to watch me read